Hi, I'm Adrian and I'm back with the second part of the tutorial. Sorry that it took so long because I was very busy with some project. So what we have now, this animation. Let's see. Okay, so let's see how you can add our frequency. So we can draw another line or just duplicate this one. I'll draw another line. Let's set this to corner to corner. So I'm pressing I'm holding shift to make it straight. Okay, so I'm drawing it now in 2D, but of course you can make whatever change you want. Okay, so after you draw the line, you go through particle flow by pressing 6 and by holding shift you can see a plus sign appears near the cursor, so just drag and drop the event to make a duplicate. Copy. Okay. So connect this with render event. Okay, so also we need to delete them. Now we want the new speed by icon to be animated by the second line. So let's go to motion panel, assign controller, sorry, let me select first the helpers, speed by icon 2, and by going to assign controller and path constraint, delete this the first path and add path, select the second one. Okay, now we see some problems. So in order to fix that, we're gonna make a duplicate of speed by icon of the first event by holding shift again and drag it over the second one like so and set copy, yes. And now we'll select the new duplicated speed by icon, the green one, the third, so speed by icon 3, and we'll do the same, delete path and add path. So now we can see the correct animation. Okay, so more mistakes you'll see from my part, the less mistakes you'll make, so you'll know how to fix it. Anyway, so everything looks okay, except we need to link the second animation to another frequency. So we'll select our point. Let's rename this to mid frec, and duplicate it by holding shift and move it. Okay, so this will be high frec. Go to motion panel, position, Z position, and choose sound. I already convert all the sound to 16-bit. So let's select high frequency 16-bit and close. Okay, now we need to go to data test, edit flow, and change the object selection to the high frequency. So this one. Okay. Now, now about the multiplier. I said that that we need to divide by 100 in order to get a better correct multiplier. But the problem was that it can get higher than the correct range or lower. So in order to fix this, we're gonna go to material editor. Sorry, not material editor, particle flow, mapping, and let's right click on another map value and show the parameter wire dialog. Now let's select U, and we need to connect this to the second high frequency point. Transform, position, Z position. Okay, so if we look now, the mid one, position, Z position, we divided by 30. So let's disconnect. You can leave it like that, and when you connect it to the second one, it will disconnect it automatically. So let's connect to this one and paste the expression here. Now, like I said, the problem is that sometimes it will get higher than 1. So you'll get some weird particles moving to the start of the path or to the middle. So to fix this, we're gonna use an expression. So what we want it to be what will be the minimum of the minimum value the division results, or 1. So I keep forgetting that parameter wiring is using max script for expression, like we write here, and not the expression script. So we don't have a minimum function, so we'll use instead the if, but let's save this value into a variable like so. So if x is greater than 1, let's make it smaller, like 999, because u coordinate of 1 is it's exactly the same as 0, because it's cycle around. So if it's greater than this value, then you're gonna output 0.99, this value, else we're gonna output x. Update. Okay, so now we fixed that problem. Let's do the same for the event one, the previous line that we did. So mid frequency, let's close this for a bit. Okay, show on parameter, did I forget to connect it? As I remember, I've connected in the first part. Okay, then let's connect it again. Okay, let's. So if x is greater than 0.99, then 0.99, else x. Okay. So let's close this. And let's see what we have. So now we have this animation. So for lower frequency, you can do the same. So I'll do it without commentary, to not lose time. So create the path. I'll create it from the front view. Duplicate, copy, connect, okay, delete, add, select the new one. Okay, so let's make a different color. So you need to be at frame 0 when connecting it, because looks like max will offset it. Let's color it a different, pick a different color, like so, blue. Also we want the test operator to be, we don't have the new point, so let's clone point, copy, this will be low frequency. Let's go to motion panel, position, Z position, double click, choose sound, low frequency 16-bit, close. Okay, now let's connect everything. 6 data test. Okay, select object, low frequency. Also close this, go to material, show parameter wire dialog, U, and low frequency. Let's see, low frequency, transform, position, Z position, divided by 30, x equal, if x more than this value, else x. Okay, connect. You can also put different materials if you want. So for this you'll need only to duplicate this material, rename it, should be a new instance, well, let's say like low frec mat. Also you'll need to make a duplicate of this material, because it's an instance of the first one. So if we rename this, for example, to gradient, we see that. Okay, so it to make a clone, so we'll rename this to grad, set it to blue. Okay, so put some different colors as you want. So you have different color values for a different frequency. So select the material, static, operator and drag this new material. So now if we render, we see a different material, different colors. Okay, so this will be all for the first technique, because it's a simpler one. Let's start to make the second one. This will be a little harder, but with more control. I'm gonna reset everything. Let me save this. Reset. Yes. Okay, so we'll start again by making a particle flow system by dragging a standard flow. Okay, we don't need shape, we don't need rotation. In this case, we'll use position object. So we're gonna emit from a plane. Let's create this plane. Why we're doing this? Because we'll use a texture to create the particles, to distribute the particles, and also color them. So we'll use an object like so. So let's go back. Position object, pick object. Next, let's set the density by material. If you want to have material on the plane and also control the distribution of particles, you can use a submaterial. So let's drag a new material through our plane and create a noise map. Set the coordinate source through explicit map channel and set the size to 0.05. Let's disable the show end result so we can see the map. Also, we need to increase the contrast, so we'll set it to 0.6, 0.65, like so. So we've set this to explicit map channel because we will use the plane channel rather than object XYZ. Sometimes in procedural textures you can also use the object's relative coordinates to the pivot point. So in this case, just use explicit map channel because we want to use the vertices UV double coordinates. Okay, so let's see what we have now. Let's change the to emit from to start from 0, emit stop from 0 and amount 100. Let's see what we have. So let's set the to display the material in viewport so we can see what we have. If we will increase this, we'll see that they emit exactly from white values of the material. leave this to 100 for now. Next we want them to follow the spline. So let's drag and speed by icon again. So let's drag another line, corner, like so. Okay, let's also animate this by animation constraint, path constraint, like so. It's not that important to decrease the speed or to increase it, because we in this technique we will not use the delete by age data test like in previous technique. So you can see now it follow. We also want next, let's save this. Because we now want to add a spawn operator and spawn by travel distance, so make sure you are at frame 0, because this operator can crash your max if you change the setting while you are on another frame. So we want to spawn by travel distance, like so. So let's see. Okay, too much. So let's set the step size to 10. Like so. Also, we don't want to inherit speed. Later we'll set this to a small value. I'll tell you why. Also divergence 0. Okay. So you see, one problem is that they move with the operator. So because they will stay in this event, so we need to move them to another event. So let's put a display operator. UDD display. Okay. So now you can see they staying behind. Also, I want to rotate this plane in the direction of the spline. Okay, and I'll also want to increase the step size. Be careful with this value. Decrease it by small values. And speed by icon, I want to acceleration limit to increase it to a very high number, so we'll get a nice, we'll get some nice corners, like so. Okay. So now we have this animation. So let me tell you a little bit about the second technique. The second technique will use Krakatoa to magma flow from Krakatoa to animate the density of the particles by age. So what's happening is that we spawn those particles at different frames. So by spawning them later, they get a smaller age. So the first ones will have a bigger age. The last one will have a smaller age. So later we'll export this to partition and load it with Krakatoa Perti loader. So this will lose some. Will be more procedural, but will lose some change ease of change, because we'll need to partition them and reload them. It's not a difficult task, but there are many advantages by doing this, because we have a better control of each individual strand or line of particles, and we can play with individual shadings, with Magma and other things. So also we can duplicate just the PRT loader, make different shapes. Okay, so I told you earlier that we want to inherit it a little bit. Why? Because inherit the velocity, because later we will want to use motion blur, and motion blur need velocity information. So if we'll set velocity to 0, inherit 0, will not have any direction, so we cannot multiply this vector by, if 0 multiplied by any number will be 0. So to do this, we can set the multiplier here, but it leads to some, not problems, but it's better to set here to 100% and set the speed, set the speed operator here, like so, and set it to inherit previous, set to 0.00 x001, like so. I don't remember exactly what was the reason, but as far as I remember, it gives some problem of exporting motion blur later setup. Okay, so we now have this. Let's increase the step size a bit more. Also, okay, sorry for many cuts, video cuts, because as I said, after a project, and this is a little messed up technique, and I'm just reviewing my project and seeing what I did last time, because I don't remember very well. Okay, so let's add some material. In this case, we'll use material object, mapping object, in order to get the material coordinates from this plane. So let's pick the plane, and we also want material static, like so, and this material will be to color the strands individual by we'll use in this case a noise, but you can use any animated map. So I'll use noise. Okay, so I'll set so set this to explicit map channel, small value, and apply this to this. Okay, so now if you set this to Krakatoa, set Krakatoa, bring each front, set force additive mode, and if we render, we see that they are still violet. This is because we create new particles and send them to another event. So we need to instance this material by holding shift and dragging it here and set it to instance like so, and now we see the new material. Okay, let's set to the materials to something more different to see the new ones. Maybe bigger contrast like so. Let's see. Let's increase this a little bit. Okay, so it was too small. I also want to increase spawn rate like so. Okay, so now if you scroll to the last frame of the speed by icon animation, we should see this shape like so. Okay, very good. Next, we want to export this to partition with Krakatoa. So let's open Krakatoa graphic user interface. Go to save particles, and we want the following channel. We don't need normal. We want age like so. So color, yes. Density, I don't think we don't need density, so let's remove this like so. Okay, so let's save this. Let's say strand 1. So we have 100 frames. Set this to render just one frame. We just need the last frame like so, and save particles. Yes. Okay, now we should have yes, frame 100 like so. Now let's get set it back to render scene particles. Minimize this. Let's disable for now particle flow, and let's create a Krakatoa PRT loader like so. Select this file, and we want to load single frame only. And don't forget to check keep velocity channel, because we'll run into problems later. Let's set it to be 100% in viewport. Let's try to render, and we see exactly the same. Okay, let's position it to the origin, so to be in exactly the same spot like so. Next, we want to add magma flow, magma modifier. Open magma editor. But before we'll do something in magma flow, we need to have our animated point in viewport. Okay, by sound. So let's create point. Now if you tried to make the first technique, you saw that the animation is very how to say it, very fractalish, very rough, it's jumpy. in the first technique it was a little bit fixed by the follow speed by icon operator, because they grow with standard speed, the constant speed, but they were deleted faster. In this case we don't have a constant speed, we have them already. So in order to smooth the to smooth the audio values, we'll use a simple, not so simple, but a technique to connect, to simulate a snap to the audio point if it's higher than current value, and if it's lower it will just go down with a fixed speed. You can later also add some gravity and other type of behavior if you want. So I was thinking how to make this easier to follow, because we don't want to make some recursive connection and make too many controllers to be easier to understand. So I'll use 3 dummies for one sound, because this is easier to understand. So let's go to motion panel, position, Z position. We'll do the same as as on previous technique when assigning the sound, audio float. Choose sound. Let's use mid frequency for now. Okay, absolute value, minimum 0, maximum 1. Close. Okay, now we'll need 2 more points. So why you need? So what we're gonna do with these 2 points? One point will control through max script the second one, and also it will get information from it. So we'll do this because we don't want the same point to get and set information on itself. So Max doesn't like this and doesn't allow, but there are methods to do this, but it's not recommended. So in order to keep it stable for Max, we'll use another point. Okay, so this will be the helper, position helper, pose help, and this will be the driver. This will be the sound provider. Okay, so let's go to sound driver, go to motion panel, position Z, and assign it script controller, so float script. Create a new variable, we will call this muse, create, and assign it to a node. So we'll use the sound, the pose helper, sorry, sound provider. Okay, like so. We do this because by linking to a node or to a controller, we'll get this script will get updated as soon as this controller will be changed, or node will have some changes on it. So we want to react to the movement. So for expression we use this expression. Let's change the point 0022. Sound sound provider, sound driver, position helper. How did I name it? Already forgot. Let's see, post help, like so. Okay, so what this will do if the sound, the point with the sound on it, which is animated on Z, it's greater than this helper position, then we want to snap this point to Z position to this one Z position, so it will get, if frequency, the amplitude will be higher than the current one, it will snap to the current amplitude. But if it will be low, it will be, if it will be lower, it will just decrease with a constant value, position Z, decrease by 0.01 value. So, and we'll set the current value to the point, this point position, post helper position, Z position. This is safe because it will not go below 0. The sound provider will not go below 0, so we can safe assume that it will not go below 0 because it will jump up. Evaluate, close, and now we should see, we'll get closer. We should see the smooth animation. Is too slow moving. The interval is very slow, and we don't see very much of changes, but it's doing it right. Okay, so now we'll go. Let's save first. Save, and we'll go with magma flow setup. Open magma flow editor, and what we need, of course we need the age. Okay, input channel, we need age, like so. Also we need an input object. This will be our point animated, smooth animated point, sun. Okay, sound driver. Next we want to query object query, property query. So we want position, and we want to convert this to float. So with breakout vector, we want the Z coordinate. Okay, now let's multiply this Z value with 100. Then we'll subtract from 50. I'll tell you later. This is for controlling the multiplier and the position offset of the animation. Okay, so subtract from 50. And we're gonna multiply it by 160. So why 160? This is because max works in ticks, so age is in ticks. So 1 second has 4,800 ticks. So our animation is 30 frames. So we divide this by 30. You can see it here. If we select the speed by icon, you can see 30 frames. So we divide it by 30 and we see 160. Okay. Next we want to get the age and convert it to float, like so. And we want to compare it if it's greater or equal than this value. So if it's greater, then we'll put a switch like so, and we want to keep the density, the input density. So input channel density, like so. Else we want to set it to 0. Okay, now it will be not a smooth interpolation, but cornered one, let's say, like, or 0 or density, not interpolated. But you can later put a blend to interpolate the values to get a more smooth interpolation. Okay, so switch will go into an output node of density. Okay, so final density, like so. Let's save this. Now let's see what we have. Okay, looks like the age wasn't exported correctly. If we will go into debug mode, we see that all the particles have the same age, which is incorrect. So let's try to export this again. So magma loader, go up, let's remove it for now. Yeah, go back to particle flow, enable it. Let's try to set it to range. I'm not sure why it did not export the correct age. So let's set it back to save particles. Age is selected. Okay, so let's save it. Yes. Yes. Okay, so now let's load back. Okay, now I've remembered what was the problem. So we want I've loaded the frame 100, and in 50 frame range it doesn't have any information. So I want the frame 15, like so, single frame, and let's see what we have. No, we want to set it back to, let's see, Krakatoa. No, not this one. Okay, we want to set it to render. Let's see what we have. Nothing good. Nope. Okay, let's debug more. Let's open the Krakatoa launch particle data view utility. Okay, let's select for now particle loader and press update. Let's see age. Okay, so we see some of ages are animated correctly. Okay, so should work. Try to create a global override set and delete it, just in case. Okay, so now it's working. It's so stupid. Let's connect it back. Let's see what we have. We have now this animation. See, I think I didn't disable particle flow source. Also, I want before exporting, don't forget to set this to display none, so it will not export those particles. Okay, I was opening better. Let's see. Yes. Almost okay. Disable this. Set to 100. Let's see. Too much. The multiplier is too big. Set it to 17. Let's render it now. Okay, finally we got this animation. Yeah. What next? I'll go have some rest for now. Next part I'll show you how to make this kind of thing, so like squarish movement at the ends, and also how to animate motion blur. Okay, thank you and see you in the next part.